Alright, welcome. In this video, we're going to be working AP Pre-Cal Homework 1-1, computing lots of average rates of change. So we're going to start with this problem with the temperature of water in a tub is modeled by function W, which is increasing, and W is measured in degrees Fahrenheit, and T is measured in minutes. Okay, so it starts asking us, what are the units of the rate of change of W? So the units of the rate of change of a function are the units of that function divided by the units of its input. So units of output divided by units of input. So this will be degrees Fahrenheit divided by minutes. And then in the next lesson, when the output function is itself a rate, maybe that's where we'll need to be particularly careful. For now, we're just going to divide units of output divided by units of input. And when it asks, find the average rates of change of W on each of the subintervals indicated by the data in the table, that means go from 0 to 4, 4 to 9, 9 to 15, and 15 to 20. So we'll have 4 different average rates of change we're going to compute. So I'm going to dig in here and say, all right, maybe start off with red on the intervals 0 to 4. I've got W of 4 minus W of 0 divided by 4 minus 0. It's f of b minus f of a over b minus a, y2 minus y1 over x2 minus x1, however you like it. So this is going to be, look it up from the table, 57.1 minus 55 would be 2.1 divided by 4, and I think that'll be as far as we're going to go with that. Sure that you could do something else with it, but I don't think you would be required to in this class. All right, so from 4 to 9, W of 9 is 61.8 minus 57.1. It would be 4.7 divided by 9 minus 4 is 5 degrees Fahrenheit per minute. So, I'm not sure which is bigger. If we got a calculator out and figure it out, decimally, I'm pretty sure 4.7 over 5 is going to be bigger than 2.1 out of 4, now that I think about it. So, the temperature was increasing faster during the time interval 4 to 9. And then, let's see what else. Oh. And then from 9 to 15, went from 61.8 to 67.9, so it increased by 6.1. When t increased from 9 to 15, that's an increase of 6. And then the last one, from 15 to 20, is from 67.9 to 71.0, so that'll be, I'll go to 70.9 would be 3, so 3.1. 3.1 divided by 5. All right, and when was the temperature in the tub increasing the fastest? All right, well, I would have to say during the time interval 9 to 15, because the average rate of change was the greatest, and I can tell that it's the greatest because it's the only one that's bigger than 1. The rest of these are all less than 1 because the numerator is less than the denominator. Greatest average rate of change. Now, number 2, here's the graph of y equals f of x. Find the average rate of change of f on the closed interval -1 to 8. All right, well, we're going to say from -1, okay, there's that point here, maybe I'll even label that -1, -1, up to x equals 8. It's here at 8, 6. We're just going to find the slope of the line that connects those 2 points, right? y2 minus y1, 6 minus -1, divided by x2 minus x1, 8 minus -1. That's going to be 7 over 9. Average rate of change of f on the closed interval 3 to 5. It's going to be much greater. It's much steeper between those 2 points. So I'm going from the point 3, 1 to 5, 7. So 7 minus 1 over 5 minus 3. So that'd be 6 divided by 2, and that's going to be 3. Yeah, so that's definitely steeper than 7 over 9. Average rate of change of f over the closed interval 1 to 3. Okay, that'll be negative, because we are decreasing here. Alright, so the point is 1 and 5, so I'm going from the point 1, 5 to 3, 1. So 1 minus 5 divided by 3 minus 1. Yeah, of course you can do 5 minus 1 over 1 minus 3, and it's going to give you the same thing. It really doesn't matter. So 1 minus 5 is negative 4, 3 minus 1 is 2, slope negative 2. You already knew that from a long time ago. Alright, and then the average rate of change of f on the closed interval 1 to 6. I haven't labeled x equals 6 yet, so that'll be 6 and 5. Oh, okay, good. Yeah, so we're saying that it went from 1, 5 to 6, 5, so 5 minus 5 over 6 minus 1 is 0 divided by 5, and 0 divided by anything is going to be 0, as long as we're not divided by 0. And that makes sense because, the function didn't change between those 2 points, so its average rate of change would be 0 there. There we go. Now we've got some functions defined more algebraically, and we're just going to find the average rate of change of the function on the specified interval, and we're going to simplify our answer. Okay, so f of x equals x squared. So I'm looking for f of 5 minus f of 2 divided by 5 minus 2. And that's going to be, okay, f of 5, I would take 5 and square it. That would be 25 minus f of 2 would be 4 divided by 5 minus 2. So I've got 21 over 3, and that's going to be 7. It's cubed. And now I'm interested in taking g of 3 minus g of negative 1 divided by 3 minus negative 1. And, alright, g of 3 would be the negative of 3 cubed minus the negative of negative 1 cubed. Okay, we're going to need to be careful with that, and I'm going to need to zoom out also so that you can see it. And we're going to be dividing by 4. Alright, so the negative of 3 cubed would be negative 27. And then plus minus the negative, okay, we can do that now. Negative 1 cubed would be negative 1. And divide by 4. And so that would be negative 28 over 4 is negative 7. Alright, 3t squared plus 2 over t on t ranging from negative 1 to 4. Alright, so f of 4 minus f of 1 divided, no, f of negative 1 over 4 minus negative 1. That's going to equal, alright, when I plug in 4, I'll get 3 times 4 squared, alright, 3 times 16, that's 48. Plus 2 over t, so 2 over 4. Alright, minus f of negative 1. I need more room here. That'll help. Alright, when I plug in negative 1, I'll have 3 times negative 1 squared, so that's 3 times 1 is 3. Plus 2 over 1, all divided by 5. That's going to be, alright, well, 48 plus 2 over 4, I don't know what else to call that, but 48.5 minus 5, all divided by 5, and that's going to be 43.5 over 5. Alright, I think, if this were the quiz, this would be a perfectly fine place to stop, I think. Pretty sure for AP Pre-Cal on the AP exam, they would give you a number that was either really easy to compute and simplify, or they would give it to you on a calculator section. It's kind of somewhere in the middle. But what I'll show you something you could do is we could multiply this thing on top and bottom by 2. So we wouldn't be changing the fraction, we'd be doing a little something with it. And 43 times 2 is 86, plus another one would be 87, divided by 5 times 2 is 10. And if we divided 87 by 10, let's say that that was equal to 8.7. If we had to. Maybe not, I don't think we had to. Okay, so for this one, g of t equals 3 over t plus 1 on t running from 0 to 2. So, okay, yeah. -1 to 4. Oh, okay, yeah. Ignoring the fact that that's got a vertical asymptote in there. All right, so on 0 to 2, we're looking for g of 2 minus g of 0 divided by 2 minus 0. That's going to equal 3 over 2 plus 1 minus 3 over 0 plus 1 divided by 2 minus 0. All right, so we've got 3 over 3 is 1 minus 3 over 2, and that's going to end up being -1. All right, 5x to the 2/3. Okay, now we're get reminded of something we haven't done in a while. Fraction exponent. So I'm interested in computing f of 8 minus f of 1 divided by 8 minus 1. And f of 8 will be 5 times 8 to the 2/3 minus f of 1 is 5 times 1 to the 2/3. It's visible, divided by 7. All right. And okay, so remember PEMDAS, I'm going to have to deal with the exponents before the multiplication by 5. So 8 to the 2/3 power is going to be 5 times the cube root of 8 squared minus 5 times, well, 1 to the 2/3, I know that's going to be 1 because any power of 1 is equal to 1. So 5 times 1 all divided by 7. Okay, so if I take the cube root of 8, that's going to be 2. 5 times 4 is going to be 20, minus 5 is 15 over 7, and that's going to be fully simplified. There's nothing else we can do with that. All right, with 4x to the 3 halves, I'm looking to take g of 9 minus g of 4 divided by 9 minus 4. Okay, so that's going to be 4 times 9 to the 3 halves minus 4 times 4 to the 3 halves divided by 9 minus 4. I'm glad I've got this on here because I did notice when I was grading the last test that this was something that happened. That was a common error when we were evaluating something like 4 times 9 to the 3 halves. We were kind of like multiplying in there and taking 36 to the 3 halves, but that's not the same thing, right? PEMDAS, we have to do the exponents before the multiplication by 4. So I'm going to say, all right, 9 to the 3 halves, I take the square root of 9. And I'll cube that, minus 4 times, take the square root of 4 and cube that one, and divide by 9 minus 4. Alright, so square root of 9 is 3, to the third is 27, so we've got 4 times 27, minus 4 times square root of 4 is 2 to the 3 is 8, divided by 5. All right, well, 4 to the 27. I mean, not 4 to the 27. I definitely can't do that, but even 4 times 27, that would be 80, 108. Yeah, 12 times 9, that makes sense. All right, so 108 minus 32, I think is going to be 76. So I'm going to call that 76 divided by 5. If you needed to, one thing you could do, yeah, that makes sense, because you could factor out the 4 from this and say the numerator is going to be 4 times 27 minus 8. You can apply factoring to the numbers. And then it would be 4 times 19, which is just a little bit shy of 80, and 76 sounds about right. All right, so we've got a couple more here. H of t is the kind of function we're going to study in depth in a couple of chapters here. So t plus 4 over t minus 2 on 3 is 6, so h of 6 minus h of 3 divided by 6 minus 3. All right, when I plug in 6, I'll get 6 plus 4 is 10 over 6 minus 2 is 4. Minus, when I plug in 3, I get 3 plus 4 is 7 over 3 minus 2 divided by 6 minus 3. All right, so 10 fourths. 10 divided by 4, that would be 2.5 minus 7. 2.5 minus 7. I think it's going to be negative 4.5. But what we should do is we should definitely go to a common denominator, right? Especially if we're unsure, which I kind of am. So I'm going to call this maybe 5 halves minus 14 halves divided by 3. Well, divided by 3, that's like multiplying by 1/3, so I'm going to write it like that from here on out. So 5 minus 14 would be negative 9. And then I can simplify that. I could call that negative 9 over 6, which is going to be, if I divide both of these by 3, that's negative 3 halves. Right, and then h of x is 1 over x squared plus 1 on negative 5 to 5. So for run, it's going to be, all right, 1 over 5 squared plus 1 is 26. Minus, when I plug in negative 5, I'm going to get the same 1 over positive 26, because if I squared negative 5, I'll get positive 25. So I've got 1 over 26 when I plug in negative 5. And I've got 5 minus negative 5, so I've got 0 over 10, and that's just going to be 0. Right, next we've got a table of data for this function f, and it's like, based on the table, are we looking at linear, quadratic, or neither? So we're going to need to look at the average rates of change and look at the spacing of the x intervals. They are evenly spaced, so if the average rate of change form a clearly linear pattern, then we'll know that f is quadratic. All right, so I'm going to just kind of write in here, average rate of change. And all right, from 0 to 2, f increases from 5 to 7. So 7 minus 5, I'll just do the computation over here. 2 minus 0, I've got 2 over 2, that's 1. Okay, then 8 minus 7 over 4 minus 2. All right, so 8 back to 7. Oh, and so I've already said it once, but I forgot that the x's are evenly spaced by 2. So f increased by 1 over 2, so 1/2 here. 8 back to 0 is a decrease of 8, so average rate of change is negative 4. 0 to negative 15 is a decrease of negative 15, divided by 2, negative 15 halves, and then negative 20 would be a decrease of 5, so negative 5 over 2. Okay, yeah. Get rid of that. Okay, so we're not seeing a constant average rate of change, so linear's out. As for quadratic, we would need to be seeing like the same pattern here where like I'd be adding the same number, subtracting the same number. Here I decreased by 1/2, and there I decreased by, I believe, 4.5, or 3.5. No, decreased by 4.5 to go from positive 1/2 to negative 4. There was tripping over that same arithmetic there, and that's not that's not the same. Okay, so the average rate of change is not forming a linear pattern, therefore it's going to be neither. I did not expect this to be a neither situation, but we look at the average rate of change and we can determine that there. All right, values of the quadratic polynomial g of x are shown in the table below. What's the value of k? I'm going to look at that one. I think that was probably an error. It was supposed to be quadratic, but it didn't work. All right, so it's value of k. All right, so we're looking at a quadratic table, so we're going to look at the average rate of change. To go from 8 to 10, we increased by 2 when x increased by 3. And then from 10 to 7, we decreased by 3 when x increased by 3. From 7 to -1, we decreased by 8 when x decreased by 3. Yeah, okay, so we see that each time we are going down by 5, in the numerator at least. Okay, so the next one we know is going to need to be -13 over 3, right? Because I'm subtracting 5 in the numerator each time, that's the pattern. So I need to subtract -1, I guess -13 to balance off the divided by 3. Okay, so for this problem, it's actually probably better to look at it the old way we did with the first and the second difference. I'd kind of been trying to avoid that because it seemed like that wasn't really what they were going for with AP Precal, but that's the only way. And so that's going to need to be -13, right? Because, yeah, the first difference is decreasing by 5 each time. So if I'm decreasing -1 minus 13, that's going to be k equaling -14. So it's -5, and we need to ensure that that was also going to be -5, thereby giving us the 13, which gave us k. Oh, there you go. All right, now we'll try again. Determine whether the table of values represents a linear, quadratic, or neither. Is it? Okay. I see that what this question was. It was like find the average rates of change, and that was what we did in blue. And I thought it was this section of problems where it was like, hey, here's two tables, determine whether they're linear or quadratic. Hopefully we get one of each, right? So over here, the x's are evenly spaced. We're going to compute the average rate of change underneath. All right, so -5 to -4 was an increase of 1 when x increased by 2. -4 to -1 is an increase of 3 when x increased by 2. And then -1 to +4, that's an increase of 5. And again, x increased by 2. And 4 to 11 is +7 when x increased by 2. All right, the average rates of change, they are forming a linear pattern. Each time the numerator is getting increased by 2. Right? There's a constant difference on each interval. You can say average rate of change is we are going up by 1 each time x increases by 2. We're seeing that same constant second level difference. That's going to be quadratic. Okay, and then B, we're going to go over here and we're going to look at the average rates of change on this thing, and we're going to see, maybe I'll just switch up the color. I haven't used orange yet. Average rate of change underneath, and say, all right, 13 down to 9 was a decrease of 4 when x increased by 3. 9 to 5 is another decrease of 4 when x increased by 3. We're seeing the same average rate of change. That's what it means to be linear. So 5 down to 1, again, decreasing by 4 when x increased by 3. Feeling good about it? Yes, this is linear. Constant rate of change. All right, number 7. All right, this is particle motion. And although I feel like particle motion could conceivably be on the AP exam, it's not something that you're going to have to like be confronted with on the quiz or the test. It's really something that we're just getting you started thinking about now, partially for AP Calculus, because this is a big thing here where the object moves along the x-axis. Okay, so its position at time t is given by x of t equals t squared minus 8t. I'm going to change this to plus 15 right now. I apologize if you worked it with minus 15, but this is going to work much better with a plus right there. And so we've got... Okay, actually, I was going to take a step back and draw you a diagram here, because this might be a new situation to most of us. So we've got ourselves an xy plane. Okay, and this is a familiar environment to us, hopefully. And we've got an object, and I'm just going to illustrate this with a pink dot. And the object is going to be moving along the x-axis, and I wish that I could just grab this thing and move it around. Let me see if I can do that. Yes, all right. So I think it's gonna change its color. But okay, so this object is moving back and forth along the x-axis. Okay, and it's gonna have, like right now, it just seems like it's, moving very slowly, maybe, but then I say maybe it's sped up and starts moving really fast. Over here, it's in a place where x is positive. Over here, it's a place where x is negative. Oh, right now it's on the origin. And so I'm going to ask you different questions about that, and they'll just give you a function in this class that gives you probably position versus time. Okay, so this object is just moving back and forth along the x-axis, and hopefully that clears up a little bit of confusion about this problem, because I know I've already talked to some people, and I know that this is not a situation you may have thought about before. All right, so let's jump in. Let's do it. Okay, so to start, if we're going to find the times when the object passes through the origin, right? Object at the origin would be when its x-coordinate is equal to 0. Okay, so x is a function of t, right? X is actually the output variable here, and where time is the input variable. So what we're going to do is we're going to say, okay, x of t equals 0. We've got a formula for x of t. That's t squared minus 8t, plus 15 equals 0. This will work way better if we can factor it. And then I'm going to factor this thing, because I can think of two numbers that multiply to 15 and add to -8. That would be -5 and -3. And that would be when t was equal to 5 or when t was equal to 3. Those would be the times when the object was passing through the origin. Hey, I'm not going to draw you a graph of x versus t because I think that would be needlessly confusing. Maybe at the end I'll do that, but I don't think that would be the thing to do. Because I think it's easier to just think this passes through the origin. That's where its x-coordinate is 0. Okay, the origin, the x-coordinate of the origin is 0, and because it's on the y-axis, and then we just solve the equation. All right, find the average rate of change of the object's position over the time interval 0 to 4. Let's see. Yeah, right. Based on the average rate of change, what direction was the object moving during the time interval 0 to 4? At least on average. So what we're going to do is we're going to say, okay, well, we can compute x of 4 minus x of 0 divided by 4 minus 0. And if you want, you can use, the factored version of x of t that we came up with over here. And I might actually highlight that if I have that ability. Do I? Actually, I do. Yeah. Okay, well, that's not the best highlighter I've ever seen, and that's not what I was even trying to highlight, pardon me. Let's try to get rid of that. All right, so I could use this. I could use this expression if I, really trusted my factoring. But personally, I'm probably just going to go back to the original statement of the function, because that was written in ink on the paper, and we know that's factually true. So I'm going to go over here. X of 4, that's going to be 4 squared is 16 minus 8 times 4 plus 15. So 16 plus 15 is 31 minus 32. That'll be a net total of -1. Minus x of 0 is going to be 15. All divided by 4. Okay, so I've got, that was -1 minus 15 is -16 over 4 equals -4. All right, so the average rate of change was negative. All right, I'll draw the x-axis here. Think about the point. So its average rate of change was negative, which meant that it actually, the change itself was also going to be negative, the net change. Okay, and if the change in position was negative, then the ending value was less than the starting value. And so the point moved over here. So to me, if the average rate of change of position on the x-axis is negative, I'm going to say that the object is moving to the left. That's because of that orientation we have that we think about the x-axis, the greater values come from the right side. And then at what time did the object reach its leftmost position? Okay, well that would be kind of when it went like that, right? I mean, probably didn't look like that because it was on the x-axis the whole time, but it was going to the left and then it turned around and went to the right. That would be at a absolute minimum value of x. Okay, when it went, I was going to start to say moving left to moving right, and that's still true, so I'm going to write that out. And so we could think about that as when x went from decreasing to increasing, and that is what's going to happen if you think about the graph of x of t being a parabola. But also when x of t was at its minimum. And finding maxima and minima, that's something really we're going to be interested in the next lesson. But I kind of figured I'd throw it out there right now. So I'm going to just remind you that x of t equals t minus 5 multiplied by t minus 3. If you factor it up, I think this is going to be the easiest way to see where the minimum occurs. If I graphed, okay, this is going to be graph of x versus t, but the zeros would be over here at 3 and 5, right? And so the time when x is at its lowest point is going to be right there halfway between the zeros. That's going to be at t equals 4. You could also have done negative b over 2a. This problem is really an extension, so if you weren't really feeling that, don't worry about it. If you're good with computing the average rates of change like we have been throughout this whole homework and looking at linear versus quadratic on the tables, that's all we really need. All right, so I think that we're getting to the end of this homework here. Suppose p of t is quadratic. Average rate of change of p on the interval 1 to 4 is 5, and the interval 4 to 7 is 2. All right, so we need to notice that both of these have a width of 3 in x, and I wrote that and you just could not see it. That'd be a little better. So increasing by 3 over there, increasing by 3 over there. So the average rates of change of a quadratic polynomial form a linear pattern. So if the average rate of change was 5, and then on the next one it's 2, that's a decrease of 3. So the average rate of change on the next interval of the same width, 7 to 10, and I might even draw that on. So kind of subdividing x, there's 1 to 4, 4 to 7, and 7 to 10 right there. Great. Okay, so they said that the average rate of change was 5 on 1 to 4 and 2 on 4 to 7. And we decreased by 3, so we're going to need to decrease again by 3. And so the average rate of change of p on the interval 7 to 10 will be negative 1. And the average rate of change of p on the interval negative 2 to positive 1, that's an x interval, it's going to be back here. And so I'd need to go back one level, okay, and to go to the left, it looks like I'm adding 3. Or I can think about what would I subtract 3 from to get down to 5, and that would be 8. So on that interval, the average rate of change is going to be positive 8. Now, suppose q of x is a quadratic function, fill in the missing table value. Okay, great. I think, did we already do one of these? Yes, we already did. It's the one with k. It's the same type of problem. Okay, but no big deal. If it's quadratic, we can look at the average rates of change. But I actually found that first difference, second difference was the way to go here. Okay, I decreased by 2, then I increased by 3, which was a second order difference of positive 5, so I need to keep that going. That's the idea. So that means that this will need to increase by 5 to get to 8, so I need to add 8 to the 18 to find q of 6, which will be 18 plus 8 is 26. Okay. And yep, that's it. That's going to be all for this homework, all for this video. Thanks for watching. Hope it helped.